Hi, welcome to CS Glitz. In the last video, we learned about tuples. In this video, we'll focus on sets. We are going to cover these topics on sets. Unlike list, set is an unordered sequence of objects. We can declare them by using curly braces. Elements are separated by a comma. Now, A is a set type variable that contains 3 integers. We can use built-in function len to get the number of elements in a set. A set contains only unique elements. Also, there is no guarantee on the ordering of the elements. Sets are useful when the order or frequency of the data doesn't matter. For example, we can use them for creating a dictionary of unique words out of large string. Usually, we use set data structure to query whether an element is present in it or not. You might be wondering why we need sets when lists can also do that. Let's explore how Python searches for an element in this list. We'll make a list of 5 elements. First, we'll try to search for 3. It will search from left to right one by one and stop after finding 3. Let's try to search for 7 this time. Again, it will search one by one from the left. When it reaches the end and couldn't find 7, it implies that this element is not present in the list. List can get an element by index instantaneously, but they are not good at searching elements by value. Let's see how set handles that. Sets usually reserve more space than they require. In this example, we are reserving space for 10 elements. We will try to add 14 first. Set uses a hash function to find an index for the given element. To simplify this, let's assume that a hash function returns the last digit. So we will store it at index 4. Similarly, we can add 27 to index 7 and 33 to index 3. When we try to search for 27, we need to compute the hash again, which will be 7. We will compare the element at index 7 with 27. If they match, then the value is in the set. We will search for 55 next. We will compare the element at index 5 with 55. If the position is empty, then the value is not in the set. Let's try to add 44. There is already an element present at index 4. This phenomena is called collision. There are many ways to handle it. The simplest one is to put the value in the next available slot. When we search for 44, it will keep comparing elements starting from index 4. If found, then it's in the set. Searching 55 will start comparing elements from index 5. If it finds an empty slot, then it's not in the set. The previous example was given just to understand how sets work. Python uses more sophisticated hash functions and collision handling algorithms for better efficiency. We can see what hashing does for a given value by using the built-in hash function. For integers, it usually returns the same value. But for any other type of value, it will also return an integer for an easy mapping to index. However, not every data type is hashable. Sets are heterogeneous, which means they can hold any type of data. Lists are not hashable, but tuples are. We can use membership operators to search whether a value is present in a set or not. Not in returns true if the element is not present. We can use a for loop to iterate through the set. This is how we can declare an empty set. Set constructor can take any iterable object and generate a set from it. Let's write a program to get all the unique characters of a string. After declaring a set, we can insert new items by using add method. There is no guarantee that it will preserve the sequence of data. To insert multiple elements, we can use the update method. Remove method will remove the item with the given value. It raises a value error if there is no such item. Discard method is similar to remove, but it will not raise an error if the specified value does not exist. Pop method will remove a random element from the set. To remove all the items from the set, we can use the clear method. Let's talk about comparison operators. They work based on set theory instead of value comparisons. Less than operator returns true if the left side is a proper subset of the right side. Less than or equal to operator returns true if the left side is a subset of the right side. Greater than operator returns true if the right side is a proper subset of the left side. Greater than or equal to operator returns true if the right side is a subset of the left side. Equals to operator returns true, both have the exact same elements. Not equal to operator returns true if any of the element is different. Let's take a set of all the integers from 1 to 9. Now we will take a set of all the even numbers from 1 to 9. Now E is a subset of n. We can check it using the less than or equal to operator. Or we can use the isSubset method. Conversely, n is a superset of E. We can check it using the greater than or equal to operator. Or we can use the isSuperset method. Let's understand some basic set operations by creating a new set of all the prime numbers from 1 to 9. Now, a bitwise AND operator will return the intersection of both sets. This is the same as using the intersection method. Notice that this will not modify E. If we want to modify, then we can use the intersection update method. Or we can use bitwise AND equals to operator. Similarly, a bitwise OR operator will return the union of both sets. This is same as using the union method. Notice that this will not modify E. If we want to modify, then we can use the update method. Or we can use the bitwise or equal to operator. A minus operator will return the subtraction of one set from another. This is same as using the difference method. Similarly, if we want to modify, then we can either use the difference update method or we can use the minus equal to operator. To get all the prime numbers from 1 to 9 which are not even, we can simply subtract the even set from the prime set. A bitwise XOR operator will return the symmetric difference between two sets. They are the elements that are present in either of the sets but not in both. We can also use the symmetric difference method. Similarly, if we want to modify, then we can either use symmetric difference update method or we can just use the bitwise XOR equals to operator. Similar to list, we can unpack a set as well. But it should be avoided as the elements can be in any order. Also, keep in mind that extra elements are always returned as a list. We can also create sets on the fly using set comprehension. The square of a negative integer is positive, which is why a set contains only the unique elements. Let's write a program to take a long text from the user and print all the unique words except is, a and the. Let's take a string from the user, split it into a list of words and then convert that list to a set. Now we want to remove all the stop words like is, a and the, which can be done by minus operator. Notice that it is including the because T is capital. We can avoid that by converting all the words into lowercase characters. As an assignment, try to print all the words in ascending order. Links to the source code for the examples and assignments are in the description. Feel free to drop suggestions or questions in the comments. Thanks for watching. See you in the next video.